I'm always constantly like, hey, anyway, qualified.
Like every weekend, can you bring me a Taco Bell? Talking about like right now, you can't just walk. No problem.
Screw the residents.
Is it your job to drive them around? Technically, there's some new way, but you know what?
I'm glad.
Sure.
Were you alright last year? First
Oh, wait.
So why did you came here?
I don't know.
Me too. Any expectations of today's meeting?
I expect it to be done around 11:50. So.
Okay.
Or so. Are we doing our picking topics?
Yes. So put a black star on one and keep one with. This one will be for me, and I will give enough copies for your members. So do not rush. You have the whole meeting to wait and
I would just like to say that I've picked last nearly every time.
That's
Did
true.
it help?
I mean,
That didn't hurt.
if you have something, I'm not gonna like own that. Just
So everyone has a copy, right? So this one is the main goal.
I was hoping there's
So main goal is to fill this this little form, and this will be most important and most interesting, at least for me, part of the rest of the course. I hope that it will be interesting for you as well. There will be also a lab tonight associated with the additional homework due next week, but it will be rather easy. And you have to. Yes, yes. It is.
I didn't get that.
You can. Yes, because you should like, throw fingers. I don't have another copy.
Okay.
It's just continuation of this stuff, and I'll print more for the lab.
Okay.
So, if you do not feel comfortable with an idea of two homeworks due the same week, let's consider this additional homework as a lab report.
That helps a lot.
Huh? It helps a lot, right?
So, is there a third one that we had in addition to
No, only two. I mean, two homeworks, not three.
Wait,
Because this
we
is.
have one already.
This is what you already have.
Okay.
I just reprinted it once
Oh.
again.
Got it.
No.
Yes. This one?
I'm not so mean.
That's a lot.
So just these.
Both we went.
Yeah, and I'll explain and print things as for those who will attend the evening. So I'll go over these steps during the lab. So what is this lab, which also has a lab report, or if you want additional homework? It mimics the research procedure. Basically, it is what you were presenting last time and what UNV was doing. So main thing that will start in a couple of minutes will be selecting a topic. You will project your scientific interest or develop them into one or maybe two-dimensional problem, which means that you will use the same code and you will change only the V variable, the potential. And UNV was showing how he did like barrier, potential well, harmonic oscillator, and one can do more things. So it will be only one potential per person. And then you will modify initial conditions and see how the system responds to it. So it's basically an assignment for a month. And tonight we will basically repeat what UNV was doing in preparation of his report. We will thoroughly do all little numerical experiments for harmonic oscillator because it aligns with the class material. So do not, and for the report you just copy paste screens and provide them. Okay, so here is the form, and I'm not sure if you will have time to do anything except going across this list. So you, on one way, you do nothing. You take no notes, you will back and watch me perform. So minimal involvement. On the other hand, it is maybe the most important involvement because you are selecting the project that will contribute substantial portion of the grade and of overall course effort. If there are multiple opportunities, if you have your own idea, you are very welcome to pursue. I'm just suggesting some directions. And this invitation to put to connect your name with one or several projects is just to help you to get through. If you are very clear what you want from this life and how you can assist with physical chemistry, scientific computation, you do not need it. So it's just ideas. If you are already involved in research and you see connections, how you can add this meta component to what we already do, it will be ideal. Yeah, and I did send this with the previous year. So some of these slides will be ugly and written, some will be a little better. So there are no restrictions for shape of potential, and they can model 90% of scientific problems that one needs practically solve. So in the electrochemistry, you apply bias voltage, and the attractive part of the elements in the molecule get change relative depth because external electric field shifts, adds linear component to the potential. And then it is easier for electron to jump one direction rather than another. So it explains oxidational reduction. Jumping electron from molecule to electrode or backwards or to the solvent. Polar running either conjugated film or details where, if anyone selects, I will put it in person. If you are looking into polymers, coatings, and conjugated polymers and their properties for conductivity, the activity of material to conduct electricity is always slowed down by randomness, by noise, by disorder in relative energies of sites, molecules or molecular units, because they, along the chain of polymers, experience different environment and energies of this, like barriers and dips, are slightly different, even if it is a homogeneous, because of things. And then it will be random deepness that slows down motion of elements. This is very easy project to implement, but a little challenging to recognize and analyze. There is no theorem that we have to use single Gaussian wave packet as an initial condition all the time. There is what the theory allows to have two or any shape as initial Gaussians, or any shape. And if you set up two Gaussians moving opposite each other, like two running waves, this is an example used to store so-called quantum information. It will be an illustration of transitive paradigms. So when this wave packets meet, they will show something very different from the original. There is a very rich interpretation, and if you ever want to teach a course like that, it will be a good illustration of those propositions. So you already explained, maybe not in all details, but if we do have either complicated, carefully designed potential, or just roughly setting up well and depth before and after the area. It is a traditional representation of chemical reaction. So we have energy of reactant, energy of product, and energy of activation barrier. So by making wave packets to overcome the barrier, there is majority of chemical reactions can be described in this way. And if you have the reaction of a ring, you can pull these values either from literature or from your experience from some measurements, plug it in and see if the reaction rate will match what you expect. Which reactions? Charge transfer, catalysis, combustion, and there are much more. If you are experienced organic chemist, you know 100 times more reactions about cycle conditions. Suppose Santa Claus didn't bring you a new cell phone and instead brought you a new smartphone. Yes. What happens to a molecule if you irradiate it with infrared laser pulse or infrared radiation? If you irradiate a molecule with UV-Vis, there are electronic transitions across the board. If the frequency of laser or incident light is smaller than the light, there are still some interactions. Okay? How the heat from the stove and from the oven transmits. So this electromagnetic radiation launches, increases amplitude of vibrations. If it is in resonance with normal mode of oscillation, the electromagnetic radiation is skimmed very quickly at the very first thing that electric field right from anything in the space means that instead of zero potential everywhere, it will be linear. So it will actually acceleration in the direction where if it is oscillating, it will forward and if it is an oscillator, due to this leaning everything backwards, it means it will shift the equilibrium position. So if you even start in the ground state, start this swinging forcing back, it will accumulate more and more thermal heat in infrared excitation. In the rest of the labs, I will provide a little things, additions to the codes or suggestions how to use it during the labs. But most of the time, you can, as soon as you select your problem, you can not listen to me, but pursue your project. Right now, we are not going into the details. It is superficial overview. But if you were super alert and careful looking at everything on the screen, you have noticed that it was always one curve. So it was strict mathematical definition of function. For each argument, there is one value of function. But it is not always a good model for chemistry. Because if we consider our potential as dependence of energy of interatomic distance, this dependence of energy can be very different if we excite more. So there could be more than one potential energy surfaces. So one needs one argument and two functions, or more than one. If it is just ground and excited states with UV energy of excitation, they will be just floating above each other and there is no problem. But if we have energies between different potential energy surfaces, vanish. If there are two different electronic configurations that lead to different minimum, different shapes of potential surfaces, but they are in the same energy range, then the potential sparks do intersect. And when we have it arrives to intersection, it should have an opportunity to jump from one surface to another. This is what Marcus Nobel Prize in chemistry for doing in 1956. But it's still an active research in this direction because he did it only for parabolas, and no one forbids us to use more advanced shapes. So there will be a way to modify the code by taking into account more than one potential surface and jumping. This is always a competitive research direction. The applications are the sector, different dye-sensitized solar cells, injection, it's all applications. One of the examples is can read this abbreviation. I can explain it. So if you need explanation, prefer to explain to everyone. If you have a metal organic complex with metal and organic shell, there are electronic states when charge is localized on shell or on metal, and there are states where it transfers. And there are possibilities to explore specific metal organic complexes. Like I know that in Dr. Rogers' lab, there are metal organic complexes in enzyme that catalyze some simple reactions. Could be fluid. This is something breast students in my lab are doing, just and other will help to get through it. It's semiconductor methodologies open, and there are these examples of ligand to metal charge transfer, where instead of ligand there is a semiconductor surrounding it. If you like orbitals, if you're looking not for easy life but for hard life, you can find different applications. Maybe it will go. I don't know why I'm showing that the excited states in these systems means that wave functions or occupied and unoccupied orbitals experience dynamics and redistribute inside the orbit. The lesson from if they are localized like blue and red spots are localized in the same ranges, it will be easy if they by the chance to go to opposite directions, it will stop emitting light. So when keep swimming, I'm going deeper rather than wider, but I will return to the right. If the flexible material, it can be a molecule, metal organic compounds, dye, conjugated polymer, which are very soft, or even quantum dot, not any quantum dot, but quantum dot of the specific wet halide perovskites, which are much more flexible than typical semiconductors, then promoting system from ground to excited state has an additional effect. There are contractions and elevations of bonds, changing angles, going from changing symmetry, and modification of the geometry of this complicated system can be summarized in average direction coordinate when all atoms are specific type elongate or contract. And then in this paradigm, one can apply concept of wave effects that you are already experts. So one jumps from ground to excited state, then we experiences motion in potential surface. And why it is important? Because depending on where it will stop, it will or it will not emit for light media applications. The same thing. Simplifying this direction coordinates. Very different application. Previous one was more for the physics. This one is more for chemistry. And this movie is probably the best thing I did in my career. If you can make research related. So it is what is happening to a metal organic complex if it is irradiated by very high intensity laser. Then it cycles between ground and excited state several times. And although this system is very stable, you cannot break it by fertilization. But if you excite it, it comes to, you can overcome the dissociation barrier. The bonds from metal carbon are broken. As time passes by, it splits off multiple products. Another hand one consider is signal metal ion is which kind of carbon. I'm not showing it here, just in case there's some skepticism. Those has spread. So it's, I don't know what you will choose, but in this you would see up for an anti-selective anti-net-based attack. This is similar idea, but here the laser radiation is used not to break molecules apart, but to induce polymerization. So precursors, and this is set against silicon. So silicon instead of carbon side zinc are white is used to loosen the bond, then they are starting to connect each other. The idea is, it's not idea, it's also from transparent liquid with precursor. One light radiation that gets through black second cup. And it is used to use as ink to draw integrated circuit, shine light, and so if we use catalysts, likely need to overcome the barrier where the energy of reaction is a little higher than product. If your product is lower in energies, if it is an exothermic reaction, it can be spontaneous and considered as combustion. The reaction is always energy. And you can do this all just by selective protection. There is also a way. There is a way to look through this little form. You'll see that for several potential directions of research, there is an ambiguity. There is like Roman 1 and Roman 2. Taking potentials just by human design or extracting it from ab initio calculations. So if you are thinking about doing something to shape the foundations of universe, or just get a peer-reviewed paper or things like that, which are almost there is a chance to get a help from postdocs or graduate students that we will be happy to assist, and get the function of potential, how the energy depends on coordinate, extracted from ab initio calculations. You would be, I do not doubt your ability to do it yourself, it would be just taking time. But if someone is doing research and has things that look like potential energy surfaces, he or she can immediately transfer it to you, and then it will be like research with an assistant, with a trampoline. How many years?
Mission Arm is essay. I'm going to get to Pro. 99, proceeded, 3, 2, 1, ignition. Right away, Houston. Bets are good. X5.
You know what it is, right? So it's whatever mission. When you're traveling in space, you're using combustion. When you are driving your car, you're using combustion. To ignite, you use spark plugs, which can have a misfire. If it is a misfire on the ground, it's not a problem. You just pay a little to a mechanic or buy a new car or just work. If it happens in space, it puts in danger to a return of pollution. So instead of things that we need to ignite intentionally, there are mixes of fuel and oxidizer that ignite.
Mission Arm.
The pipette is there for a reason. I don't want my hands anywhere near this thing. You can really see there is this very fast reaction which generates loads of nitrogen and also ethane. And so all of the products here are gaseous, and you get a tremendous expansion at the same time. Because it gets very hot, it glows so brightly and produces a big brown.
Hydrogen, and here's what is used for like space missions. They just inject it through in a controlled way, but one doesn't need to ignite, they self-ignite it. So there are
Pipette.
Active researchers here in DSU who model these reactions by molecular dynamics and extract potential surfaces. And this potential energy surfaces can be funneled, transferred to those, if anyone will decide to follow it. So it will be one-dimensional potential with, for example, here it is a transfer of a proton from this monomethane hydrogen. So the proton will transfer to the oxidizer, and there is a barrier for this reaction. And then you just take it as potential energy surface and launch the wave packet and see what happens. And this is just a demonstration of what may happen. So as you was showing, wave packet may reflect back from the barrier. It may pass through, right? Or it may just slow down. And there is a way to translate this wave packet dynamics into like space travel. So another direction of your independent research project, and everyone will have independent, right? So it's to launch creativity and things like that. So several examples before this moment were related to specific interpretation of the X coordinate. The beauty of the wave packet tool that you taught each other how to use on Monday on presentations is that one can use the same code with minimal changes to describe drastically different phenomena in nature. And one can interpret and use this code for different interpretations, for different interpretation of reaction coordinate. So what we, on the couple of previous slides, reaction coordinate was actual chemical reactions or interatomic distance. But originally we used the code to describe motion of electron. Basically, if you do this transition, you just change your mass. Right? Mass of electron and mass of proton or more heavier atoms are 2,000 or more times different in the time scale. So if one interprets the X coordinate as position of electron in space, then there is another chapter, stream of applications. Then one can explain physical transfer of charge in space from one part of molecule to another one. Not in just different quantum states, but literally see how electron distribution looks like. And one can look on the thin film of semiconductor, as we described in when we were going over DOS sandwich. One can look for dye-sensitized solar cell, where there is one portion of potential corresponds to semiconductor, another to dye. One can look on, I'm not showing it, to a doped semiconductor, where you have this hump of atomic attractions for electron, and then in one place, if you go a little deeper, which will be like p-doping, and in another level higher, which will be like and one can fabricate p-n junction, which is a major foundation of modern technology for any resistors, solar cells, or any graded circuits, thermal electrons. And if one decides to go into this direction, there also will be abundant availability of help. There are several postdoctoral students who are developing data that can be directly imported into your model. There are several trampolines if you decide to use them. No one took it. In previous years, if one attaches specific chemical utilization to carbon nanotubes, they start emitting light, and they are becoming single photon emitter. The work that used in this effect. This is a foundation for telecommunications in the future. This is dye-sensitized modeling, where there is a semiconductor dye attached to it, and then one can create with packet localized in a semiconductor, and as time passes by, it will come to a potential part that corresponds to a dye. You can watch it going in real time and check how it depends on the conditions of simulation. This one I like very much. So it is two-dimensional, and it shows how initially equal distribution of positive and negative charges in the ranges that correspond to semiconductor into a dye change, and electron moves to the part that corresponds to, so to say, acceptor, and who remains on the donor. So this degree of charge transfer processed in the form of wave packet shows dynamic information of charge transfer. And since there are d metals, we see stuff like d orbitals. Okay, and we are approaching to the end of the list, which to few other projects that are neither reactions nor linear transfer of charge in space. I listed as a little bit more options, but basically the rest of possible projects that I will cover, there are two directions. One direction is more pedagogical. If you plan to teach physical chemistry from wherever in your life, and you would just write examples. By the state of art of by the situation, the quantum theory was first applied to hydrogen atom, and it was processed through Bohr model with the partial covenant, which is not quite correct, but it gives main concepts. So there is a way to implement Bohr model in terms of these wave packets and see how electron moves along the circular orbits, if it is mandated. In fact, it does much more complicated things, but one can make an illustration for model and obtain a proof why there is a quantization state. And this is a good illustration. I think I was showing some movies that whatever. If not, I will repeat them in the next step. But the definition of the, I was trying to explain, to bring an idea that definition of x-axis can be drastically different while keeping the code the same. So we overviewed x-axis as reaction coordinate. We reviewed x-axis as position of electron in space. Now we can define x-axis as an angle. If the electron moves along circular trajectory in your orbit, so then we'll have natural periodic boundary condition because electron doesn't leave this trajectory. When it exits, when it arrives at angle pi, immediately jumps to angle pi and then continues rotational motion. Then one will see this later turning less. This circular motion is naturally connected with magnetic field. One can illustrate how presence of magnetic field slows down and accelerates this oscillations that forms these waves. Some students were taking this project in the past, but it is not complete. One can go much further and deeper in that. And if the action corresponding to angular momentum for this wave packet is set up to be discrete, integer, then they show beautifully symmetric shapes that stay with time. If one takes something fractional, they are ugly, as you have noticed, and they will not survive. I'm going to show something very, very new, and it is the most complicated. I'm not sure if I would be brave enough to take it if I would be in the class. In order to survive in scientific activity, one needs to either be super excellent in preferred direction, or one needs to chase whatever is fashionable by today, or combine both. So it looks like a fashionable thing in physical, chemistry, material science will be so-called two-dimensional materials in magnetic field, where electrons can move without any resistance, so similar to superconducting materials. So there are so-called, I'm going to use terms and concepts that were not yet introduced in the course. They will be possibly introduced later. The dependence of kinetic energy on momentum is typically quadratic, right? E squared over 2m. Not always. There are some materials where instead of e squared over 2m, it is absolute value of p. So instead of parabola, it is a cone. And if you connect on this parabola, it will correspond at the tip that it is a parabola with infinitely small mass. So massless particle, which it means you can accelerate it with zero energy effort. So the material, one of such materials, graphene or bismuth telluride, and those are dispersion. So it's dependence of energy on the momentum, and instead of parabola, it has a peak of span, which means near this momentum, one needs zero energy to launch it for motion. I'm just getting acquainted with the system and trying to split this energy, this dispersion curve into pieces. So if you scan energy, it's shapes, and this one looks like. So it's the science of materials. So if one applies magnetic field which induces circular motion, the electron will move around this dip, but to launch this motion one will need zero energy. Therefore this motion will be persistent. It will keep moving forever, and it can be used to store information. So research, one needs to use modified version of the code which has motion in 2 dimensions instead of 1. And it's a little more challenging to explain what is going on, how it works. But it is definitely a very competitive thing if you want in the future to convert your research projects in something like competitive on a global scale. This is high impact direction. Okay, so I'm done with this presentation. I do have slides for formal lecture. It was just an introduction, but I think it is enough. I'll do the rest when we meet on Friday. Did you write your notes, or you need more time? Is there stuff with not yet?
I genuinely have no idea what I'm I'll keep my trend last.
I think we need to complete it by. You need to make up your mind. Huh? Huh?
I can just choose it.
You can select several. I will check which.
But could I just take one?
Yes, yes, please,
Okay.
please. So, by today's lab, it is preferred but not mandatory. But by the next lab, by next Wednesday, you need to be very clear what you want.
Is there any relation to quantum computing in this chemistry?
Absolutely, yes. So the last one, the turtles are related to quantum computer, and the Schrödinger cat were two states in one parabola.
So,
But the 2 states in one parabola are a little old and boring. It was already done, and this one will be like really. You can mark several, and we can. I will be very happy to chat by email or in person. Probably no one visited me in the office yet.
Are you in sound engineering?
Yes.
what times?
To visit? Send me an email.
I see.
I'm not ever needed there. But I will come and match your schedule if you need to meet.
Dr. Gillen, you showed me the non-linear analysis for
Uh-huh.
is that this one?
Yep.
When I was
Oh.
And if you're not sure how to formulate, you can just write this.
Well, you got 10 wrong,
Yeah.
which is a bummer.
Yeah.
Yeah.
I still disagree.
I still think we're right, but whatever, another fun. And then I must have because that was all that wrong, I must have marked it wrong on my skin tone. But whatever, I need to get a 70 or something on my finals. So not worried about it. Wow, you chose everything.
Oh no, one of that. I don't have any specific idea. So yeah, no, so it's good to do some big calluses. So.
And I probably noticed on the slide, mentioned on the slides the room number. Not mine, but of the postdoc. So Denver 054. Yeah. And he's sitting most of the time on the, and he will be happy to.
Every time you do that, they're always so far ahead of you that by the time you catch up to where they
So
are,
is this kind of like a final project
Yes.
that we're gonna
Yes.
work independently and
And then you will complete the report and oral presentation.
I would suggest not doing that.